Good morning, everybody, and welcome back to Next Door NetAdmin. Today is part 2 in our 3-part ACME deep dive, and today we're going to be talking all about the ACME protocol. We're going to be talking a little bit about what kinds of validations you might have on a certificate. We're going to go into a good bit of depth on the ACME protocol so that you have an idea of what's happening behind the scenes and can more effectively troubleshoot it if something goes wrong. And we're going to talk about the specific kinds of validations that you can encounter under the ACME protocol. So there's a lot to cover today. Let's just hunker down and dive right in, shall we? I mentioned last week that before a certificate authority signs your certificate request, it will do some validations that are dependent on the CA. It's not just dependent on the CA, it's usually also dependent on what you have purchased if you're purchasing a commercial certificate. The 3 basic types are domain validation, or DV. There's organization validation, or OV. And then there's extended validation, which is EV. As you go up in these levels of validation, there's a lot more steps that need to be performed for verification. And that means a lot more manual human work involved. If you're doing organization validation, you're going to be looking up details on the business. You're going to be consulting business records. You might be consulting a Dun & Bradstreet number. Who knows? In extended validation, there's even more validation to be confirmed. Like, can you actually communicate with a person? Phone calls, emails, possibly even hardware security modules or smart cards involved, depending on what the certificate is going to be used for. The simplest method is domain validation, where the only thing that's being validated is just the domain name on the certificate. And everything else is not being validated or being signed to by the certificate authority. They'll only put their signature on, this is the domain name for this certificate, that's all there is to it. This is why ACME certificates are only domain validation. ACME itself stands for Automated Certificate Management Environment. The key part to that being automated. You need to have this set up in such a way that it can automatically renew and validate the certificate without human intervention. So that precludes the use of organization validation or extended validation certificates because those require manual human verification effort. So, domain validation only. Cool. That's pretty much all there is about the certificate authority part of that. And so the rest of this video is going to be specifically about the ACME protocol itself. There are a few certificate authorities that implement ACME. The best known and the one that started the process of actually codifying ACME and developing it into an internet standard would be the nonprofit organization ISRG, the Internet Security Research Group. Their public certificate authority is the very well-known Let's Encrypt. It was set up specifically to make the process of acquiring certificates easy and cheap, as in free. Free is a good price. We like free. And as a big part of this, it had to be automated from the get-go. Because if you're verifying and issuing thousands upon thousands of certificates to make them ubiquitous so that everything is secured and encrypted, then it has to be automated. There's no way that you can hire all the people in order to do all of this if the certificate is free. And if the certificate's not free, then you're not encouraging adoption. So, ACME as a protocol is often associated with Let's Encrypt. And in the examples that I go through, I am going to be using Let's Encrypt because that's just the CA I use. But it is important to note that the protocol we're discussing can be used with different CAs. There are other CAs that implement it. There's 0SSL is one that I know of. I think BySSL is another. I don't have a full list at hand because I usually just use Let's Encrypt. But it's not a requirement. You can use ACME with other certificate authorities. And so the protocol we're going over should be useful for you no matter which certificate authority you eventually go with. An ACME registration flow starts with registering an account. And this is something that is oftentimes a little invisible. And I've had people come up to me, even in my own company, and say, "What do you mean an account? There's no such thing. There's never been any such thing." And all I can go is, clearly you haven't read the actual specification. An ACME certificate is tied to an account. You must have an account in order to register a certificate. Why? Well, this is mainly a function of being able to manage the certificate effectively. And I'll explain what I mean by that, because it's not management in the traditional sense. When you register an ACME account, you register a contact email address. It's not public. The email address is only there if the certificate authority needs to get a hold of you for some reason. For example, Let's Encrypt has used this on a few different occasions to tell people, hey, we discovered some flaw in our validation process and we're reissuing a whole pile of certificates. That's an important thing to know. I've also gotten notices, hey, your certificate is 19 days away from expiry and it hasn't been renewed yet. It's 5 days away from expiry and it hasn't been renewed yet. That's also kind of useful to know. So registering an email address so that the CA can contact you, the admin, if there's a potential issue with the certificate is very important. There's nothing else you receive from it. Nothing. It's not used for marketing. It's not used for, trying to upsell you on stuff. It's just to let you know of technical issues that need an admin's attention, or at least verification that everything is going the way that it actually should be. But with that being said, a contact email address is optional. You don't have to provide that. When you have an ACME certificate issued, you can revoke it. If the certificate has been compromised, or if you have lost control of the private key, you can revoke it. There are two ways of revoking a certificate. You can revoke it with the private key of the certificate itself. If you have control of the private key, you should be able to tell everybody, do not trust this anymore. Either the owner has reason to remove it from circulation, or if it's been compromised and an attacker wants to revoke it so that nobody trusts it anymore, okay? If it's been compromised and you've lost control of the private key, anybody with that key should be able to revoke it. There's absolutely no security downsides to this. There might be a usability downside, but that's a separate concern. But what if you don't have control of the private key anymore? Let's say somebody broke into your server and you're trying to recover access to it, but while you're going through the support line for your server administrator, you need to make sure that people stop trusting that certificate as soon as possible because it's compromised. But you don't have access to that private key anymore. In that case, the private key for the ACME account can be used to revoke the certificate. So that even if you've lost control of the certificate itself, if you have access to the original account used to register the certificate, you can still perform a revocation in an emergency. So, There's a reason for there being an account. Now, the certificate itself, when you go through the process of registering the certificate, you'll typically be providing at least one, you need at least one domain name that you're certifying, and a list of others. Different CAs will have different limitations. Let's Encrypt has a limitation of 100 domain names per certificate, which honestly seems pretty generous. If I need a certificate with more than 100, what am I doing? And I can probably afford something that isn't free. Be that as it may, you're going to have a list of domain names. Each one of those domain names needs to undergo validation to verify that it can be included on a certificate. So how do you validate the domain name? Well, let's think about, what are we actually validating? Are we just validating that it exists? Well, google.com exists. Should I be allowed to register a certificate that claims that I am google.com? No, I really shouldn't. So clearly you have to do more than just verify that the domain name exists. So what are we actually validating here? We're validating, or intending to validate, that the entity which is registering the certificate is the entity that users will reach if they type that domain name into their connection, whether that's a browser or whether it's email client or whatever. If you're trying to reach google.com, the certificate that you are presented with should only be issued if it is actually residing at google.com, not on my server in my back office. So there's a few different ways of validating this. The first one is given the method name HTTP01 or HTTP validation. All this does is, hey, if the certificate authority tries to reach this domain name, does it reach the server does it reach a server which can present the correct validation tokens? So when you say, hi, I want a certificate for www.somedomain.com, the CA will respond and say, okay, here's a special validation token. Put this at the correct location in the web server. Okay, if you're doing HTTP validation, that validation token goes into a set location in the web server. And then when you say, okay, I'm ready for you to validate this, the CA goes from several different places, not just from one, because you want to make sure that this is reachable globally, not just from one specific data center that might be in the path of an attacker-controlled network. Fine. We're going to go from multiple places. We're going to try and hit the server, and we're going to look up and see if this validation token is in the given spot. And there's an actual spot where this is placed. It's a known URL that you're looking for. So if you get the validation token, what does that tell you? Well, that tells you that whoever made the request has control over the web server. It does not tell you that the certificate request came from that web server. All it tells you is that whoever made the request has control over the web server. Okay. That is sufficient to validate that if I'm going to issue a certificate for somedomain.com, I know I'm giving it to somebody who actually is in control of somedomain.com's web server. That is acceptable. Another way of doing this validation is through DNS01 lookups. A DNS validation is much the same thing, except you take that validation token that the CA gave you and you put it into a DNS record, a DNS text record specifically. what does that tell you? That tells you whoever's requesting this certificate for somedomain.com has control over the DNS records for somedomain.com, which means that they can point it at any server they wish. So you're still validating that whoever's getting this certificate has control over the server that it eventually points to. You're just validating it at a step higher up in the chain, as it were. This is more important because if you're trying to validate a wildcard certificate, something like star.somedomain.com, whether it's www or SMTP or mail or SIP or whatever, if you're trying to validate a wildcard certificate, you can't do that with HTTP. You cannot check every single possible subdomain because some may not exist. Some may go to other places. It's impractical, but you can validate it with DNS. Because in DNS, you can add whatever subdomain records you want. So if you want to validate a wildcard certificate that can validate anything on that domain, you must do it through DNS verification. Them's the rules. HTTP and DNS are the two most common ways of doing certificate validation. There is another way where you can do TLS ALPN, or there was another TLS-based validation method that I think has since been deprecated. It's not in use anymore. Fine. But HTTP and DNS are the biggies. They're the ones that you will see most often. If you're using HTTP validation, this can often be built into a web server these days. Whatever server you have running your website, set it up to request a certificate. If you're using something like cPanel, they have this built in now, and they call it Auto SSL. Okay, cool. If you're just running your own virtual private server or your own web server, there are other tools that you can install to do this, and I'm going to show some of them to you next week. If you're wanting to do DNS verification, that gets a little trickier because you need to have a DNS provider that can handle automated requests, automated programmatic requests, because we don't want to have a human in the loop. That kind of is an issue with the goal here, which is automated certificate management. There's ways of having a human in the loop anyway, but the general idea here is that you want a DNS provider that can handle automated requests, and you'll need this in what's called an API, or an application programming interface. There are lots of DNS providers out there. There are lots that support an API. GoDaddy supports API. EasyDNS supports API. Route 53 from Amazon supports API. There's a whole pile of them, and you can get various DNS providers to support this. Again, that's all in the details of implementation next week. But it's still something to consider because it's going to impact your choice of validation methods. You're also going to need to consider how the validation is going to work. You can have a web server, cool, but if it's not port forwarded in from the internet, then the certificate authority is not going to be able to reach it to verify it. If it's on a different port than port 80, it's not going to be able to verify it. There's some details in that it will start on port 80, and if it encounters a redirect and the server tells it, try again on a different, on a different domain name or a different port number or whatever, so long as it can reach it initially on port 80, then it will follow a redirect and look for the verification token at wherever it's being redirected to. But it has to initially reach it on port 80. So if port 80 is in use for something else, Or if, for security reasons, it's not port forwarded at all, then you can't use an HTTP verification. You're going to have to use DNS verification instead, which throws you into the whole API thing. There's also possibilities of, hey, maybe you are using port 80 to validate a certificate at a particular web server, but maybe you want to do it on 2 different servers. Well, if only one of them has port 80 forwarded, you can't use HTTP for the other one. And this becomes an issue if you're doing something like requesting a VPN certificate that's going to be installed on a router. Okay, well, if the router is forwarding port 80 to a web server internally, then it can't use port 80 for itself. Or it might be able to, depending on how it's set up. Regardless, these are all implementation details, but they are the kinds of things that you need to think about when you're planning a certificate deployment. It's possible that you need to set up a certificate for a server that you have access to the server, but you do not have access to DNS, or it's on a DNS provider that doesn't support API access. In that case, if you want an ACME certificate, an automated certificate, you're going to have to think about, how do I actually get this to validate? Or do I go to a commercial certificate? I don't anymore. I will put in a lot of effort to work out an alternate way of doing it wherever I can, rather than going to a commercial certificate. Because if I can get it for free and have it renew in an automated fashion, why would I not do that versus going and paying a commercial CA $80 for a certificate that will only last a year? I should also mention, ACME certificates, because they're intended to be automated, typically have very short lifetimes. For Let's Encrypt, the lifetime is 90 days, which means, yes, you're getting a new certificate every 3 months. Sooner, usually on the order of every 2 months, because you don't want to wait until the very last minute to renew your certificate, because what if you encounter a problem? You don't want it to expire in the meantime while you're trying to fix the problem. But because it's supposed to be automated, this is not a problem. And short key lifetimes also limit the potential for compromise. If somebody compromises the server, well, the certificate only had a short lifetime anyway. It's not like it would have continued to be valid for a full year. But that's a separate thing, to some extent. It's all part of the things that you have to keep in mind when you are a net admin, a server admin, a system admin. These are the kinds of things that you deal with on a regular basis. I think that's probably mostly it for now. Next week, we're going to talk about implementation. I have a few tools that I've been using for years and like quite a bit for their flexibility and for what they offer. So that's something for you to look forward to. And that's the one that'll be a little heavier in technical content, I suppose. The first of these episodes was pretty heavy on the math, I realize. And this one has just been heavy on me talking a lot. And next week will be pretty heavy on the technical details. So hopefully that's something that you will enjoy. Or if not, thank you for watching so far. But that probably should be it for today. So thank you very much for joining us. I am your next door net admin, and we'll see you next time.